Good evening, everyone. Welcome to the 10 days online lecture series on research scope in emerging areas of civil engineering. Myself, Chaitanya. So, today I'll be continuing the lecture series on this topic contamination, ecological, and human risk assessment from an industrial discharge area. So, it is a case study. So, today I'm going to discuss how we are going to assess contamination in any area. Let us suppose if you are presently working, or if you are interested in toxicology, or if you wanted to know about bioaccumulation and you want to evaluate the heavy metal contamination and toxicity assessment of a specific area. What are the things you need to consider? What are the parameters you need to consider? How you are going to approach, and how you are going to collect the samples, how you are going to analyze them, and what might be the practical difficulties you will be facing when you are doing this kind of extensive site work. So today we'll be discussing about that. So mostly this lecture will be very useful for ongoing MTech or research scholars, especially who are working on heavy metal contamination or toxicology studies. Apart from that, for BTech students also, it will give an idea, overall idea about how metal contamination is going to affect our ecosystem, so that they can able to frame a network on how to prevent those metals before entering into any stream. So let us start the lecture. So this is an overview of my lecture, which will be having general introduction about the metals and how the water bodies in any industrial areas are getting contaminated by these metals, especially, and few literature that we are going to talk about it later. Then we are going to split this work into four major parts. So the first part is identifying the contamination, and the second part is estimating the risk, and the third one is size fraction speciation. So this will be little complicated, but I'll try to explain as easy as possible. And the last part is on how you are going to remediate once if you identify any contamination. So due to rapid urbanization and industrialization continuously, whatever the spaces and especially the green spaces that are available, so their utilization are getting limited. That means whatever the spaces are available initially, those green places are continuously at a diminishing rate because of the continuous contamination, continuous discharge of effluents from nearby industries, or due to encroachment, due to the population growth, or due to many factors. So unprecedented growth due to that, especially in our country, like a developing country like India. So that development is happening at the expense of the ecosystems, and the major transformations include the natural resource management. So over exploitation of natural resources, and the existing green spaces are getting reduced due to this rapid urbanization, industrialization, as well as population growth. Apart from that, most of the industries are generally discharging the effluents onto the open grounds without any proper treatment. So they are continuously contaminating the existing water as well as soil. And another problem is the cleanup processes are very, very costly. That means if you wanted to remediate any contaminated site, not only metals, it may be either due to pharmaceutical waste, or any other type of waste. Generally, it becomes a costly affair. You cannot able to clean it at a very low cost. And especially industries such as textiles, leather industries, that means tanneries, chemical industries. So these are the major contributors. So Central Pollution Control Board has categorized the industries into Central Pollution Control Board has categorized the industries into four categories based on their way of contamination, like how they are contaminating air, how they are contaminating the water, and how they are contaminating the soil. So, with that, by cumulating all the effects, so they have categorized. Let us suppose if that cumulative value is greater than 60, then it can be considered as a red category industry. And if it is in 41 to 60, it is orange category, which are moderately polluting. Then green category are marginally polluting industries. That means most of their discharges, they do not require much treatment, or they might be requiring very basic treatment. And there are some white category industries like paper and pulp, or organic manure, or organic fertilizers, or tea industries. So generally these kind of industries does not discharge any much wastewater which require any treatment. So the problem is with the red category industries. So these are few of the highly polluting red category industries which are listed by Central Pollution Control Board. So in that specifically we'll be talking about a case study. There is an industrial area in Tamil Nadu which has bloomed with too many tanneries, and from over the past few decades they are continuously discharging the industrial wastewater from the tanneries. So mostly this study will be focusing on the tannery effluents. So India is 13%, it is contributing almost 30% to the world's leather population, and especially the major tannery hubs, as you can see, maybe in this slide, yeah, Tamil Nadu, Uttar Pradesh. So these are the majority of uh, places where they are having more number of tanneries. So approximately around 2,500 tanneries are currently available in India. And as you can check, the problem with the tanneries is they generally process the hides. They make the hides stiff. So in that process, there are different types of processes, natural and artificial processes. Natural processes uses the dyes which are extracted from the bark of trees where they can use as an ingredient. But most of the industries prefer chemical treatment because they are comparatively cheaper. So 80% of the tanneries they generally go for chrome tanning. So the problem with the tanning is, so once you apply the tanning agent, almost up to 40% can be discharged as a waste. So this slide we have discussed already. So now specifically this case study is in Ranipet industrial area in Tamil Nadu. So this Ranipet industrial area accounts for almost 40% of the leather export from our country, and almost 240 tanneries are present in and around this same industrial belt. So in this belt, we are going to talk about a small lake which is continuously receiving industrial effluents. So now we'll talk about the perspective, like what is the problem with rivers or lakes? What might be the difference? Let us suppose if both are getting contaminated. So which is going to get affected mostly? Generally, lakes are almost not hydraulically connected with any other water body. So due to that, they have very limited self-treating capabilities. So because of that, they cannot able to treat themselves, and if the contamination exists continuously, they ultimately cease their existence. So why smaller lakes are important? See, as I have told you, this is a case study about a small lake. Many of you might be wondering, why do we even bother about a very small lake that is somewhere in our country? The problem is, initially J.K. Downing et al. Around in 1980s, when they estimated the area, the spatial area of the water bodies, so they found initially they miscalculated that the larger bodies are generally having most amount of water, but once later, they have found that global freshwater lake area is, that means in small lakes and streams, it is almost more than 4.2 million kilometers square, which is even greater than the combination of all the other larger water bodies. So the smaller water bodies generally hold huge amount of water, and especially lakes are sources of fresh water. That means readily available fresh water. So these lakes and inland water bodies in our country, they covers about almost 7 million hectares, so that you can able to understand the importance of the small, very tiny water bodies, which you might not think they are not at all important, but collectively they gives a huge impact when they are getting exploited continuously. So major pollutants in lakes in the vicinity of any urban area or any industrial area are mostly household chemicals, or domestic discharges, or industrial discharges. Apart from that, heavy metals. So now we'll discuss about heavy metals. So what are the heavy metals? Why we are calling them heavy? Generally, they are denser. So what might be the characteristics? The characteristics of heavy metals are, these are persistent, they are very toxic, you cannot able to completely eliminate them. They try to transform from one form to another form. Apart from that, it is completely not possible to clean up. Another problem is bioaccumulation. Bioaccumulation means accumulating into matrices of either food or human body or animals. Let us suppose some food chain contamination is there. Uh, we'll consider the same. Anyway, we are going to talk about it later. I don't want to complicate it at the start. Apart from that, uh, apart from bioaccumulation, the another effect is on soil as well as on water as well as the vegetation that is growing in that contaminated areas. As you can see, these are the sources of heavy metals. These are the natural sources like volcanic eruptions, like that. Apart from that, artificial sources mostly include anthropogenic activities. That means man-made activities. So what will happen generally? Heavy metals are they'll getting taken by aquatic organisms, then they'll get accumulated in those aquatic organisms like fishes or something, then those will come into the food chain, then we will be consuming them, then those heavy metals will be accumulating into us, so which is going to lead to several adverse health effects. So this is the study area. So from Tamil Nadu in the Ranipet district, so this is the lake which we are talking about, Puliyantangal lake. As you can see in this figure, there are two distinct drains. So one is coming on the left side, one is on the right side. So the left one is the domestic discharge drain that is getting discharged from the nearby villages, and the right side drains are from the nearby industrial areas. As you can see, these are the existing industries. So many studies are there which have reported contamination in this lake area, that we are going to talk about that later. But the major sources of contamination are due to discharge of partially treated and untreated tannery effluents from the nearby tannery industries, and dumping of domestic waste from this residential area. Apart from that, many other industries, because there is a spectrum of industries varying from refractories to ceramics in the same area, where most of the industries generally either partially treat or they'll dump the completely untreated waste. And this work was supported by DST under SERB scheme under extramural research. So this is the status of the study area. This is the lake water. This is how the bed of the lake looks like when it is exposed to the atmosphere. That means when the water level is comparatively less. And as you can see in the last picture, the cattle is grazing in the same lake bed area. So the major reasons for lake deterioration, that means by degrading the quality of the lake, these are the major reasons. So receiving the partially treated, untreated effluents, and illegal dumping of the waste. Most of the industries generally do not prefer to treat their waste, especially small scale industries, because the problem is they cannot able to afford the treatment. Even though some common effluent treatment plants are there, which are establishing by those local government bodies, where industries of similar type will collectively get their effluent and it gets treated. But these small scale industries generally do not even able to afford to send their waste to that particular treatment facility site. So due to that, illegally they try to dump into these kind of places. And apart from that, this lake also receives the precipitation water from the nearby agricultural fields. So why do we have to go for this study? What is the need for this study? So first one is, currently most of the people have just reported that this area is receiving wastewater from the nearby tannery. So chromium was present. This is the only available existing literature at that point of time. So as it has been discharging continuously from past few decades, we wanted to assess what is the existing contamination in the water, what is the existing contamination in the soil, as well as the local vegetation that is growing in the same steady area. Then we wanted to know the physicochemical characteristics of water also in that same area, as well surface water as well as the nearby groundwater. We just wanted to know whether it is getting impacted. Then we wanted to know the exact pathway, how the chromium is getting traveled from the industrial effluent to the soil, from soil to the water, how it is interacting, how it is changing its forms. So even that we wanted to know. And we wanted to estimate the exact risk in the sense risk to the ecosystem as well as risk to the human beings. So these two things we'll be talking in the later part. So I just wanted to skip the literature survey because most of you people you can get this data from the existing paper. I just want to summarize this. So existing literature says heavy metals are persistent, they are very toxic, they are very difficult to remove, and they pose threat to human life as well as animal life. One, so how you are going to estimate the metal concentration? So that it can be considered to by measuring the total metal concentration. So once you identify the total concentration of the metal in any particular sample, either water or soil or vegetation or any environmental matrix, you can able to have at least an idea about what is the existing contamination. But by measuring the only total concentration, you cannot able to know whether it is toxic or not. So that we'll discuss a little bit in detail after this particular slide. So once it has been estimated, Then you wanted to know that metals are getting accumulated in the soil in that region. So the granular size, that means the size particles of that soil. So that is also going to affect how much metal is going to get attached to that particular soil. So then what is the size we need to consider? Most of the studies have indicated less than 60 microns you can consider as for the risk assessment studies. Then we wanted to remediate it. There are many methods of remediation like electrokinetic remediation, some chemical methods, soil washing, many available methods are there. We wanted to remediate by phytoremediation technique. So in India already many papers have been published about using casuarina and neem plants as a remediating alternative. So that we have tried in our study also and we got good results, and this is the existing study on uh, literature. Sorry for that. In 2009 itself, they have identified that the Pulyantangal lake is contaminated. So this is the methodology which we have formulated. So initially we'll be doing preliminary investigation. That means we wanted to know the extent of contamination, so that we have collected some random sampling in and around the study area to know to till what perimeter the contamination was there and how deep the contamination was there. So for that purpose, we have collected random environmental samples, like we have collected water samples, we have collected soil samples, and we have collected vegetation, local vegetation that is growing in the lake bed area. Then after preliminary identification, that means once we got the idea, then we need to find certain sampling points so that we can continue our research for the further 2 years. So for that we have identified, and then from those areas we will be collecting water and soil for the next consecutive 2 years, and we are going to do our further analysis. Then we need to identify the risk. So for that, regarding the risk part, we'll come to that in the second chapter. So there I can able to explain it clearly. Then speciation study. So I have told you that in the literature slide that we are going to discuss about it later. So total concentration is nothing but whatever the metal concentration generally you will get. So how you are going to identify the metal concentration? Let us suppose you wanted to find either in soil or in water. Generally people go for digestion technique. So they'll make a mixture of acids, then they'll add the soil sample, they'll keep it overnight, and then they're going to analyze digest that sample by microwave digestion mostly, or open digestion also. Then after digestion, they are going to filter that sample and they are going to inject it either into ICP-OES or ICP-MS, like inductively coupled plasma optical emission spectrometry. So generally ICP-OES or ICP-MS they'll prefer. Then you are going to identify the metal concentration. Now the problem is there are two different types of concentrations. So one is total concentration and another part is speciation. So now we'll talk about speciation. Speciation means in which form the metal is bound to the soil. So generally uh, metal gets attached to the soil in four forms. So first one is exchangeable, reducible, oxidizable and residual. So I just I'm repeating it: exchangeable form, reducible form, oxidizable form, and residual form. So like that, in four forms, a metal can get attached to the soil. So as I have told earlier, when we are identifying the total metal concentration, so the concentration we are going to get from that analysis is combination of these four forms. I hope you understand. So the combination of the four forms will give the total metal concentration, but that is not going to give you what is the exact risk. I'll tell you how. Let us suppose if a metal is attached to the soil in exchangeable form. Exchangeable form means that metal is getting attached to the soil with very weak van der Waals forces. So that metal can easily come out. It can able to leach under normal environmental conditions. That means that metal is easy to come out from the soil to the environment. So risk is more. Now let us talk about the last form, residual form. Residual form means while formation of the soil itself, that metal was present in the soil. So that metal is very strongly attached to the crystal lattice of the soil. So due to that, that metal generally do not come out in normal environmental conditions. You have to do extensive processes like digestion, which I have mentioned. So now, if I am giving you one sample and if you are identifying that if that is having around 1000 milligram of chromium. If that 1000 milligram of chromium, if it is present in exchangeable form or some other form, then it is toxic. If it is in the residual form, generally in normal conditions, that is not going to come out of the soil crystal lattice. So due to that, even by seeing the total concentration of 1000, but the limit for chromium in soils is around 60 milligram. That is a permissible limit. So by totalization value, you can able to say like 1000 is very, very high. So it is toxic. But the actual scenario, the risk is very, very less. So then that is a speciation study. We are going to identify in which form the metal is bound to the soil. Then after that, we'll go for remediation. Now, as I have told you, this whole work has been split up into 4 parts. So this is the first part, that is contamination identification. So how you are going to identify the contamination? The sampling locations for water, soil and vegetation. Then after that, for 2 consecutive years, 2 times. That means one time pre-monsoon and one time post-monsoon, we have collected the soil samples as well as water samples. Then, yeah, they were digested and metals were analyzed in ICP-OES. Then physicochemical parameters also we have measured. Apart from that, the metal concentrations also we have identified in the lake water as well as from the nearby regions. So this is the study area map from Ranipet district. This is the Pulyantangal lake. As you can see, these are the 2 drains that are coming from the industries merging into the lake water. This is the drain from domestic nearby villages, which is discharging domestic waste continuously into the lake. So this is the boundary of water generally during the summers, and this is during the monsoons. So these are brief statistics, I guess. Hope you can go through them. The total area, what is the depth of the lake, and it is very, very shallow lake, just 3 meters. So most of the cases in during monsoons, so this water will be overflowing onto the highway. So this is the preliminary investigation. We have collected water from the drains that are coming from the industries. We have collected the soil from the lake bed, and this is how the lake looks. As you can check, the lake is almost full, and on-field parameter measurement also we have did. These are the sampling locations for the water samples. So 2 lake samples and the nearby samples will comprising of open bore wells and government bore wells, so that we want to know whether this water is getting transported to the nearby areas. So these are the results. So luckily we could not able to trace any chromium in the bore wells of the nearby areas. Only in the lake water we have identified the chromium, and the water clogging field. That means after crossing this road, there is a shallow pond where this lake water is getting oozed from this road. So there, only those 3 samples. So they are literally lake water samples. So from there we have identified the concentration. As you can see, the limit for chromium in drinking water as per Indian standards is 0.05 milligram per liter. As you can see, we have found the concentrations even exceeding 8 milligram per liter. You can imagine the intensity of chromium concentration in the vicinity of this area. So then, as we have measured the water quality parameters, we went for water quality indexing. Water quality indexing is nothing but, let us suppose, many parameters are there, like pH. The drinking water limits are 6.5 to 8.5. For turbidity, there is some limit set by BIS. So for multiple parameters, there are different standards. But this water quality indexing will give an overall idea to the person who is not technical with just one value, whether he could able to drink that water or not. This is how you will calculate the water quality indexing, and this is our 2 years data. We have collected samples 4 times, pre-monsoon and post-monsoon in 2018 and 19 and 20. As you can see, most of the samples are of water quality is very poor, and a few samples are unsuitable for drinking also. And these are the parameters which we have measured apart from the metal concentrations in the water. So from this we can able to say that the surrounding region groundwater is, even though it is not contaminated by chromium, but that water is not fit for drinking. So this is the result of metal concentrations in the soil samples which you have collected. You can see there are huge concentrations of aluminium and iron. So why they are so huge? Because they are of geogenic nature. That means they are the soil forming metals. So that's why their concentrations generally in any environment will be very, very high. So apart from that, if you can notice, the chromium concentration almost crossed 200 milligram per kg, but the pristine soil limit, that means the world average chromium level in the soil is only 59 milligram per kg. So these are the samples from the lake bed area, and these are the soil samples from the surrounding areas. So northern part of the lake showed higher concentrations. If you remember the figure, I have showed you where the drains from the industries are merging into the lake. The samples collected from that part of the lake showed significant concentration of multi-metals. So, which indicates it is not only getting contaminated by the tanneries, but also from variety of cluster of industries. So, apart from chromium, copper and zinc also exceeded the permissible limits in the soil. Yeah, then we have segregated the soil into different sizes because as the size is the key factor in holding the metal, we wanted to know what is the accumulation in different sizes. So the finer the soil, the more is the accumulation. If you can directly notice it over here, these are the multiple concentrations of different metals in different sizes, and if you can notice, the ones with soil size of less than 32 micron showed highest amount of metal concentration when you compared with the bulk sample also. And also one more thing to be noted is, mm, yeah, the cadmium concentrations was not there. I didn't mention in the presentation, I'm just giving it for information. In the bulk samples and in the water, we have traced the cadmium, but uh, in the finer samples, cadmium was not there. So that indicates that the it indicates very recent contamination of cadmium also in the lake area. So these are the contamination assessment indices. So what are these indices? Contamination assessment indices gives uh, what what is the supposed value of that particular metal in the environment and what is the identified value. So to that we'll find a ratio, and if that lies between 1 and 2, then you can say it is moderately contaminated, and if it is 2 to 3, you can say it is heavily contaminated. So like that. So from our study, the samples which we have collected from the lake bed, they are of moderate to heavy contamination. So that means almost they are coming into the band 4. So apart from that, there are no permissible limits for aluminum and iron. So most of the cases for aluminum and iron, permissible concentration, that means pristine levels in the soil are not there because they are the part of soil minerals. So that's why for these two metals, it is not. That is the formula how you are going to identify. That is the geo-accumulation index. This is the first one. So this is contamination factor. That contamination factor is calculated by concentration identified by reference concentration, and this is the graph that shows the soil from the lake bed area is very highly contaminated. So this is distribution factor. Distribution factor is nothing but whenever you are dealing with multiple sizes, you wanted to know till which size the metal is getting accumulated. As you know, we have collected bulk samples and we have collected soil samples of different sizes like 300 microns, 150 microns, 50 microns, and the soil samples that are passing through 22 microns also. So if that metal is reaching till the deeper level, then you can able to identify that. So yeah, here you can see the distribution factors are already there. So that means metal started accumulating in the finer particles. Now, what is the problem with the finer particles? Why we have to worry about that? Because the finer the particles, the more the chances so that those particles can able to, like they can act as vectors, like they can travel easily. Like let us suppose if wind blows, they can carry these dust particles which are having metals in them, and if surface runoff is happening, as these are very light particles, they move along with the precipitation, so they carry the contamination from one part to another part and acts as vectors. So these are the inferences from the study. I think most of the inferences I have covered already while I am explaining, but still I just want to give an overall idea. The chromium is the most predominated anthropogenic metal we have identified in our study area apart from aluminum and iron, and these are the ranges of chromium in the water samples. They are exceeding the BIS standards of drinking water quality. So why we are comparing it with the drinking water quality? Because the lake water is considered to be a freshwater source where you can and they are the readily available freshwater source. So that's why we have compared it with the drinking water standards, and also other physicochemical parameters also exceeded the permissible limits, both the water from the lake as well as the water from the surrounding areas, so that water is completely unfit for drinking. And the metals such as aluminum, cadmium, copper, iron, manganese, lead, and zinc. So it is a multi-metal contamination scenario. Excuse me. Yeah, and the concentrations of metals in the lake bed are higher than the surrounding areas. So that means the lake is the one that is receiving continuously discharge from the nearby industrial areas. So most of the samples that are collected from the lake that showed the extreme concentrations. And these things we have discussed already. The geoaccumulation index is moderate to heavy, and distribution factor also indicates that the contamination reached the finest fraction. So this is the first part. So the first part we have identified the overall contamination, how the contamination is there, till what extent the contamination is there. That means in water it is there, in soil it is there, in vegetation it is there, and in water also we have monitored for 2 years continuously. I mean 2 times a year. In both the times we have identified the chromium contamination. Now the second part is risk assessment. So in risk assessment, you might have noticed in this figure particularly, you can notice almost more than 20 to 30 cows are grazing in the same lake bed area. So there are two villages on both sides of the lake, and most of the villages are farmers. So they have cattle. They generally send the cattle for feeding on this lake. So that means throughout their lifetime, these cattle will be consuming contaminated forage, and they'll be drinking contaminated water. And that milk is getting consumed by the humans, and it is getting circulated also. So now we are going to identify how to identify, you will identify the risk to the environment as well as to the humans. So this is just a pictorial representation. So industries are generally discharging the metals, and once the metals are getting discharged, they are getting dispersed into the water, they are getting diluted. Let us suppose if water is evaporating, they are getting deposited onto the surface. Then in water and soil also they are getting interacted. Then from water to the soil and to the vegetation also they are getting. And once it comes into the vegetation, that is going to the human consumption. See, these are the sources. You can say the first one is intake of contaminated water. So the cattle is drinking the contaminated water. It is drinking the contaminated feed. So how we are saying it is a contaminated feed? Because in our preliminary study, we have collected the vegetation samples already, and we have identified that metal concentrations are there. Then ingestion of contaminated soil. What do you mean by ingestion? Ingestion means whenever these cattle are plucking the plucking the grass, along with the grass, they are unknowingly consuming the soil attached to the roots of the grass, and we have seen the concentrations of metals in those soil. So that's why in these are very few studies where they have considered the ingestion as another source for the cattle. And yeah, excretion of urine and feces. That means this is a secondary contamination that we are going to discuss later. And yeah, this is relatively a new thing which we have did in our study, that is mass balance. Mass balance is what is the amount of metal that is getting into the cattle and how much it is leaving out of the cattle. As you can see, these are the primary sources. One is water, the cattle is drinking continuously in the lake, and soil, how it is eating the soil whenever the cattle is trying to plug the plants or plug the grass, the soil is also getting ingested. And the forage means apart from eating normal vegetation, these people generally cut the locally available plants and they'll use it as a feed in their homes. So like that, they are continuously eating the contaminated forage. So these are the inputs and these are the outputs. Like the cows are generally urinating, they'll give the milk and they're done. Apart from that, this is the percentage of retaining. So retaining means in the body, how these metals are accumulating in the bodies of the cattle. So that's how we have identified the mass balance. So this is the ecological risk assessment. Ecological risk means what is the exact risk to the environment. So how you are going to identify, like pollution load index. So pollution load index is, let us suppose if one area is getting contaminated due to multiple metals. So based on the factor for each metal, you are going to accumulate all the values and you will get a final single unit value. As you can see, one sample can be considered as very highly polluted due to multi-metals. So this is the second one, modified risk assessment code. So this can be calculated from this formula. TRA is nothing but toxic response factor. Based on the metal, that way that value will change, and RAC means the readily available form. That means the metal concentration in the exchangeable form. So from this we have identified the modified risk. Then this is the structure how uh, we have made extensively for identifying the risk to the humans from the consumption of milk to the cattle. So there are two parts. The first one is from the surveys and the second one is from the analytical data. That means from the samples which we have collected. So we have did an extensive survey among the owners of the cattle and from the consumers. Consumers are the ones who are consuming that contaminated milk from the study area. So from the owners, we have collected the information regarding the estimation of daily intake. That means intake of the cow, how much they are eating, how much they are excreting and all the things. And from the consumers, we have identified what is their individual milk intake on an average in a day. Then we have collected all the samples of the forage, the lake water, as well as the urine, milk, dung, everything from the cattle. That means whatever the things that are going into the cattle and that are coming out of the cattle, we have collected all the samples, and there are almost more than 120 cows. Out of that we have chosen 10 cows, and from those 10 cows we have collected all the samples and we did the mass balance and we have identified the health risk assessment. From that we identified the probable cancer risk because most of the metals are carcinogenic, especially the lead and chromium which we have identified. So from the mass balance we will be knowing what is the accumulation into the cattle and what is and how much of the amount of metal is getting out of the cattle. So from that we are going to conclude this part. So these are the survey results, not important much, but this is how we have calculated the health risk. CDI is chronic daily intake. That means what is the maximum level you can take of that metal contaminated product without compromising your health. This is the hazard index, and slope factor means based on the metal toxicity there is a separate slope factor, and this is how you identify the cancer risk. Cancer risk total of cadmium, chromium and lead, because all the three metals are carcinogenic in nature. So yeah, this is the published data from our paper, health risk from the milk samples. This is the hazard quotient value. So the limit for lead in the milk is 0.02, because there is only the standard available for milk in our country. For chromium and for copper or for other metals, the permissible limit is not available in our present country, and hazard quotient greater than 1 indicates that probable risk is there. So one is for adults and one is for the children. So this is hazard index, that means combination of hazard quotients, and for children it is almost exceeding 1, which indicates probable serious risk. And from that we have identified the cancer risk, which I have told you, it is a combination of cancer risk from cadmium, chromium and lead. So combinedly you can able to say the cancer risk, that means if it is exceeding 1 into 10 power minus 4, then there is more probability of getting cancer risk, which we have identified both in children as well as in the adults. Then this is another type of risk assessment known as risk assessment through the soil exposure. So how they are going to how you are going to identify the exact risk. See, especially the soil which are having very finer fractions. So when these finer fractions, they generally travel from the hotspots, and from there you will get the will get accumulated. Either that soil will get accumulated into you, or let us suppose if kids are there, so generally they will be having more hand to mouth activities. So whenever if these people are living in the vicinity of these kind of highly contaminated areas, so due to their hand to mouth activity, so there are more chances of accumulation of soil, that means indirectly metal, into your kids bodies also. So literature considered almost 63 microns for assessment of health risk from the soil exposure. That means either soil you are ingesting or inhaling. So we have identified the non-carcinogenic and as well as carcinogenic risk. Apart from that, we identified three major pathways. The first one is like three scenarios we have considered. The first case is we considered all the residents are from the study area. That means throughout the time, that means over the 24 hours, they will be living in the same area. Then case 2, residents are working away from the study area. That means only partially people will go work there in the study area and they'll go back to their respective homes. So that means almost half of the day they'll be getting exposed to that contaminated area. And case 3 is non-residents, only adults. So like this, we have identified hazard quotient, hazard index, those formulas which I have mentioned already. And this is how you identify the amount of soil ingestion, absorption, inhalation. See, soil can get accumulated in you in three possible ways. The first one is ingestion. Ingestion means going inside you, either via food or through inhalation or like that. The second one is dermal. Soil particles due to wind or they'll get attached to your skin surface and slowly they'll get absorbed. The metal will get absorbed into your body. Then inhalation. So these three routes we have identified and we have calculated the hazard quotient. Then cancer risk, which I have told you, the CDI into slope factor. Slope factor means that changes for metal to metal based on its toxicity, and we have identified the cancer risk also. So from this, for all these metals, we identified what is the hazard quotient for ingestion and for dermal contact and what is for inhalation. So hazard index is summation of all the hazard quotients. As you can see, for hazard quotient, the value for adults are very less. If it is less than 1, then there might not be much effect on them. But for children, if you notice, the value almost crossed 1, it is 1.12, which indicated that more chances are there for them to get affected by ingesting or any pathway. So this is the carcinogenic risk from the soil exposure. Carcinogenic means risk means we are only considering the metals which are carcinogenic like lead, chromium, etc. So from lead it is considerably less. But as you can notice from chromium, the risk is comparatively more, and especially in the children it is comparatively high. So chromium in this study area is the is major contributor for the cancer risk in the children, either due to ingestion or mostly due to ingestion or inhalation. So these are the other two cases. Like as I have told you, we have considered three cases which I have explained earlier. So these are the inferences from this risk assessment study. So this indicates all intake routes of cattle were contaminated. That means the food, the forage it is eating, the water it is drinking, and the soil it is ingesting along with the food. All these three routes are considerably contaminated. And the major source of metals into the cattle is through the soil that is attached to the plants or to the roots of the grass. And as you can notice here, this study is only on one small shallow single lake in that industrial area. Apart from that, in that whole Ranipet industrial area, there are almost shallow water bodies comprising the area of 100 and approximately 140 hectares where the similar things are happening. So the nearby industries are continuously discharging the wastes, and they also might be having they are also reported earlier for multi-metal contamination. Now you can imagine how this is going to change, because these small shallow water bodies are affecting hundreds of population indirectly. So dung is a source of secondary contamination. So the dung samples which we have collected from the lake bed, we have identified the metals in them. So after the cattle, like once they excrete, so that dung is going to start act as a secondary source of contamination. So then probable cancer risk in both adults and children. So that we have discussed already, and children are more probable to the cancer risk when you compare to the adults. So by this, we have identified the contamination. We have identified what is the exact contamination and how much contamination there is in air, in water, and in soil and in vegetation. Then we have identified the risk assessment we have done. So what are the risks we have identified? The first one is from the milk consumption. That means the people from the area are consuming the milk. That means both children and adults. So from that, what is the exact risk to them? That also we have identified. Then you might have, I don't know if you are following, we have told you during the mass balance that we wanted to know the accumulation in the So we have collected the tail hair samples, which hair samples from the cattle, and we have digested them, and we have identified the metal concentration, which indicates that these metals are getting accumulated to the cattle also. So now, as we know that risk is existing, and risk is there to the environment as well as to the humans, as well as to the as well as to the humans. So now we will know the mechanism, how this metal is getting into the environment, how it is transforming, in which form it is present in the steady area. So those things we are going to decide. So if you remember at the starting of the presentation, I have explained this. Metals generally present in these four forms: exchangeable forms, reducible forms, oxidizable forms, and residual forms. So if possible, can we take a break, sir? Sir, can we take a break? I can continue after 5 minutes. So we'll continue the rest of the presentation after 5 to 10 minutes. Thank you for listening. Mm, Yeah, welcome back, everyone. Mm, So till now we have discussed about the assessment of contamination and how you will identify the contamination in different environmental matrices. Then after that we have identified the how like we have discussed about how we are going to identify the risk to that particular environmental component. For example, if it is for soil, the risk assessment is different. Then if it is for some other food matrix sample, then that is different. Now we'll talk about the mechanism. As I have told you, the metal can get attached to the soil in these four different forms: water soluble or exchangeable, reducible, oxidizable, and residual fractions. Now exchangeable fractions are the weakest bonded fractions. That means like they can able to leach out of those soil very easily. Then reducible fractions. So under reducing conditions only, the metal attached to the soil will leach out to the environment. Then oxidizable fractions. So under oxidizing conditions. Then residual fractions. So these are residual fractions. These are the fractions. That means if a metal is present in residual fraction, that means that metal is there from the origin of that soil. So it will be very difficult to leach out under the normal conditions. So now we can infer that if metal is present in this residual fraction, then it is very safe, because under normal conditions metal cannot come out of the crystal lattice. But if the metal is present in these first three fractions, then obviously you can consider all these first three fractions commonly as bioavailable fractions. That means they are readily available to leach out under the favorable conditions. So if those conditions comes into the environment, then at that time these metals will directly come into the environment. So then obviously it is going to cause certain risk either to us or for the environment. So how you are going to identify in which form the metal is present? From this method, modified BCR technique. So and this is called a speciation study. Then we wanted to this is just a quality check parameter. So this is the result, speciation result for multiple parameters, I mean multiple metals. So there are all bioavailable fractions in chromium, copper, manganese, lead, and zinc. As you can see, the oxidizable fraction is also very high. See, from this chart you can able to see the residual fraction, that means the fourth fraction, is very less in chromium, copper, manganese. So that means these are highly adulterated due to the anthropogenic activities. So one more thing, in aluminum and iron, as I have already mentioned before, that there are not even permissible limits for these particular metals in the soil. And if you can notice, most of the fractions are present in residual forms. That means aluminum, almost 80% of aluminum is in residual form. So that generally indicates that aluminum generally do not come out under the favorable conditions, that is strongly bonded to the crystal lattice. But another thing to be noted is almost 30,000 concentration of aluminum is there. So in that 20% is present in bioavailable forms. That means that is ready to get leached out under different conditions, similar to iron also. So these are the variations of chromium in different time frames. That means we have collected the soil samples from the same locations for 2 years to know the excuse me, change in the speciation. So Here, majority of the chromium was present in the oxidizable fraction. So, mm, yeah, and if you can consider, the amount of residual fraction is comparatively very less when you compare to the concentration. And also, as you can see, uh, for this sample, the chromium concentration is almost varying from 400 or sorry 300 to 800 milligram per kg, where the limit for the chromium is only 60 milligram per kg. So you can identify the intensity of chromium contamination in the study area. So this is the speciation in different sizes. As you know that from the earlier presentation, we did the soil, we graded the soil into multiple sizes. So in each size, what is the type of bondage of the particular metal, whether it is in exchangeable form or oxidizable or residual or reducible form. So that also we have identified, and bioavailable fractions generally increased with the reduction in the size. The smaller the size, the more is the accumulation, and also the bioavailable forms are also more. That means if we are stating, if you are inferring that bioavailable forms are more, that indicates that metal is easy to get leached into the atmosphere under different environmental conditions. So what are those conditions? For example, a very change in pH level. So if a small change in pH level, so during those conditions also it will come out under reducing conditions. Like for example, when we are discussing about the steady area, I have told you that the steady area is receiving domestic discharges from the nearby villages. So if the study area is receiving domestic effluents continuously, that means they are highly oxygen demanding waste. So that means this lake is already under the reduced condition. So chances are more for leaching of metal in that particular reducible form. So these are the inferences from this speciation study. So we have identified that most of the metals are present in bioavailable forms only. That means probable risk is there to the environment. And though the metals like aluminum and iron, even though almost 70 to 80% is present in residual form, but the concentrations are so high that even less portions present in other forms can able to leach into the environment. Then this is the percentages of bioavailabilities of different metals, and this is also one important finding from our study where there is no residual fraction for the lead. So that means in that soil which we collected from the lake area, it don't have lead in the residual fraction. That means the fourth fraction. So that means when the formation of that soil in that lake, lead is not at all available. That means it has been added recently over the years due to the discharge of partially treated and untreated effluents from the nearby industries. Now, yeah, from the speciation study, we have identified that bioavailable forms are more. So now we'll talk about remediation. So how we are going to eliminate that particular crop. I'll try to wind it off a little fast. As we have identified that metals are present in the bioavailable fractions, that means they are ready to leach out. Then we have selected certain species which can able to accumulate those particular metals. So we have started with 5 different species, and we got the required permissions as it is a government area. And before planting the plants, we have collected the soil samples from the sites, and we identified the metal concentrations. Then we started the phytoremediation trials, but our earlier trials was almost a failure, as I can say, because due to many problems, because the lake depth is very shallow, so the lake becomes waterlogged, so that the small plant samplings cannot able to survive. And second thing, due to the cattle that are roaming in the steady area, so they are continuously interfering with those plants also. So human and animal interference is also there. So due to that, we could not able to get the uh, required results. But the thing we got from this preliminary study is neem and casuarina plants showed high resistance to the or high tolerance to the existing conditions. So then we have selected these 2 species only, and then we replicated the study. So this is the study map. So in the same study area itself, we have did control and contaminated. So control in the sense, when we are doing the random sampling during our first preliminary study, we identified that the extreme southwest part of the lake generally have very less metal concentration. That means water generally do not reach till the very edge of this lake due to the gradient. So the portion of soil in this area is comparatively not much altered, so they don't have much high metal concentration. So we consider that area as a control area, and the area where the drains are merging into the lake as a contaminated zone. As you have seen that we got the sample results of almost 700-800 milligrams of chromium. So then we have planted, and local women, the villagers who are working around the area, so we have given them employment. So they are the ones who will be taking care of those plants throughout this particular study. So these are few images, and we have faced many challenges like flooding of the lake bed. So sometimes it will be very difficult to collect the samples during the monsoons due to over flooding of the lake, as we have to walk almost in the knee deep of water. Then these are the pre-processing of the samples. So once they are collected, they are dried and they are digested. So these are the concentrations order. The highest concentration was aluminum and the lowest concentration traced was the lead on the control side, similar to contaminated side also. So we have did this remediation study for almost 2 years, and see, as you can see, these are the plants on the control side as well as the contaminated side. These are the casuarina plants and these are the neem plants. So these are the metal accumulations in those respective plant species, and they follows the order of the accumulation in the root is always higher when compared to the stem, and it is stem concentrations are higher than the leaves. And mostly in the contaminated region, the plants could able to absorb more amount of heavy metals when you compare to the control set. So these are just a comparison graphs between the two species. Both the species performed exceptionally well and they have accumulated good amount of metals in them. And also one more thing we have noticed, that comparing neem and casuarina, as it is having very deep rooted system, and as the lake depth is shallow and most of the times it is waterlogged in those sensitive areas, so there casuarina stored better tolerance to the existing conditions. So this is the transfer coefficient. That means how much of the metal is getting transferred from the roots to the different aerial parts. That means to the stem and to the leaf. So that also we have identified. Then this is the above ground biomass. So what is above ground biomass? How much biomass is actually growing on the surface? So we need to measure the height of the plant as well as the width and diameter of the plant. So according to that, we are going to calculate how much wood will get developed over the period of time. So from that, we could able to get almost 200 grams of chromium could able to absorbed from the plant species which we have planted. And so that means almost 1 kg of chromium could be accumulated for the casuarina and an average for 2 years of time. So these are the inferences from the phytoremediation study. Both neem and casuarina, they have survived the waterlogging conditions, but casuarina showed better performance, and both the species have significant concentrations accumulated in leaves, stem as well as the roots. So this is the order of the accumulation, and transfer coefficients are greater than 1. That means if transfer coefficients, if they are higher than 1, so they can be considered for phytoremediation studies, and even they can be considered as hyper accumulators. That means they selectively accumulate huge amounts of metal. So these are the overall conclusions. So just combination of all the conclusions which we have discussed after our 4 chapters. That means the first chapter is contamination assessment, second one is food chain contamination assessment and risk assessment. The third one is speciation study, which is going to tell in which form the metal is available in the study area, so that based on that we can able to select the remediation technology. Let us suppose in our third chapter, while like when we are doing the speciation study, if we could not able to identify the chromium in bioavailable form, then we could not able to go for phytoremediation, because if the metals are not bioavailable, then obviously plants cannot able to absorb them. So that is a crucial step in selecting the appropriate remediation measure. So these are the overall conclusions. Most of them are discussed already. So casuarina showed better logging conditions, and the milk is affecting the children over there. The soil is affecting the children over there. Both adults and children in the vicinity of the study area have more probable cancer risk. And as most of the metals are present in bioavailable form, it is very easy for the metals to get leached from the water or to the soil, so that they can come into, get accumulated into any environmental matrix, and they also enter the human food chain. So that it will be a complete study. So from the assessment till the remediation part. So these are the scopes of the future work. Indigenous vegetation as hyperaccumulators. That means the local vegetation plants which are growing in the lake, so that they can be considered as a phytoremediation study. Then bioaccumulation study. So how much is getting accumulated into the cattle? And unfortunately, as doctor is not available in our team during the research, we could not able to collect any human samples to check the human accumulation of metal. So that can also be considered as a future scope. Then cattle as biomarkers. That means in any area, if contamination is happening, and if in similar way, if cattle are there grazing the contaminated forage as well as drinking, ingesting the contaminated water, then instead of collecting all the environmental samples, if could able to collect the samples from the cattle, like simple samples like the tail hits switch hair from the cattle, so that if you analyze them, that is going to give you an idea about the existing contamination in that area. Then monitoring of other lakes in the same watershed, as we have discussed already, almost 140 hectares of water bodies are there in the same industrial area, which are undergoing through the same treatment. That means continuously getting disturbed by anthropogenic activities. So this is the outreach of our plantation activity, and thank you very much for giving me this opportunity. I thank the Department of Civil Engineering of Aditya University for providing me this opportunity. I want to acknowledge and I want to thank the DST for providing us the necessary fund to carry out our research. And I want to thank my guide, Dr. Bhaskar Das, for guiding me for carrying this huge work. Thank you so much for your patience and time. Yeah. Any questions are there, you can ask me in the chat box so that I can able to see them and I can able to answer you.